Welcome to this new video. In this video, I'm gonna explain, I'm gonna solve actually this question regarding the compound Poisson process. So let's first understand the question. We have customers arriving to the ATM machine with the Poisson process with rate 12 per hour. So on average, 12 customers are coming to this ATM machine per hour. The amount of money withdrawn on each transaction is a random variable with mean $30 and standard deviation of $50. Since we can have some negative values here in our random variable, we can say that they mean that the money was deposited instead of withdrawn. Suppose that the machine is in use for 15 hours per day. Approximate the probability that the total daily withdrawal is less than $6,000. So let's start by solving the question by summarizing the given. What do we have? We have T, the period, is 15 hours. We have lambda of 12 per hour, 12 customers per hour, and we have a random variable. Let's call it y, yi. Let's say it's normal with average or expected value of 30 and standard deviation of 50. So what does the formula tell us? The formula to find the compound Poisson distribution is, we will call our random variable x that we will need to find with parameter t, and t here, as we mentioned, is 15. So the formula is lambda times t times the expected value of y. So let's solve this. We have lambda as 12 times t is 15 times the expected value of y is 30. The total of this should be 5,400. Okay, so this is now our expected value of our new variable. We called it x. Next, we need to find the variance of this random variable. X t is equal, what is the formula? The formula is lambda t times expected value of y squared. So let's first find the y squared here. Let's come here and solve it. We know that to find the variance of a discrete random variable, we will need the following formulation. So it is expected value of x, or here we have y squared, minus expected value of y squared. Okay, here we know this, we don't know this. So to find it, we can simply say expected value of y squared is equal to the variance of y plus the expected value, the squared expected value, let's call it. Okay, this doesn't look good, so let me do this. Okay, so to find this, we can just simply use the data that we have, the information. We know that the standard deviation was 50, so this is 50 times 50, and the expected value was 30, so we square that, 30 times 30. And how much is that? That's 3,400 400. Okay, so let's go up here and apply the formula. So lambda, we know it's 12, t is 15, and the expected value of y squared is 3400. So if we multiply these, we should get $612,000. So what's next? Now we have our random variable, call it x. Using central limit theorem, we can assume it's a normally distributed with 5400 as its mean and square root of this as its standard deviation. Okay, so as we now have this information, we can apply this to find the probability that x is, what was the question, that total daily withdrawal is less than 6,000. So x is less than 6,000. What is the probability of this using the normal distribution? We can standardize it using the following. So let's do this. We have x minus the mean, the 5400, over the standard deviation 612000 is less than or equal the value that we are trying to find over, again, the standard deviation. So we can use here the z value, we can use the phi. Z is less than or equal to this value right here, 612,000, and the value is using r, which is 1. So the question asks, approximate the probability that the total daily withdrawal is less than 6,000, and the probability is 1. So with 100%, let's say. And yeah, this was solving the question. The important part is to understand how to find the compound Poisson process, the distribution, find the mean and the standard deviation using the formulas, this formula and this formula. They are very important. And thank you for listening. I wish you good luck in your studies.